Hello friends, welcome back to the bench. If this is your first time here, allow me to quickly introduce myself. My name's Raf, I'm a software engineer. I also run a tiny repair shop, to which I welcome you today. Thank you for joining me. Today we don't have anything on the bench, so if you're after that, please check out my other videos, or better yet, go to some other repair channels that do it a lot better than I do. Instead of repairing something today, I will tell you my story of chasing free energy. Yes, I got sucked into that nonsense myself when I was young and couldn't do math. Now that I'm old, I gathered a lot of experience, made a lot of mistakes, and I still can't do math. So today we're not going to be doing math. We're just going to use common sense to help one of our friends. He generously shared his research with me, and I wanted to honor it with a dedicated video. After receiving all the material, I asked him only one question. How long have you been working on this? And he said, 10 years. 10 years. That screams refusal to fail. And you have to respect that, no matter how counterproductive it is. Imagine dedicating 10 years of your life into something and then see someone just crapping on it or just waving it away as nonsense. I'd like to give it time and respect it deserves. And here we're going to try to answer two questions. One question, or question number one, why does Stark device not work? Why does it not work? And number two, why would you keep trying to make it work after 10 years of failure? This one's going to be more tricky. So the first question is pretty easy to answer, even without deep understanding of laws of thermodynamics. You will not get extra energy from a motor. Even getting to 100% efficiency is not practical. I imagine it would require superconductors, supermagnets, no gravity, no air, and even then it would be completely useless. It wouldn't be generating any extra energy, it would just be spinning forever with no purpose. The second question can be broken down into two components. The first component is human nature. No self-reflection, ignorance, and delusion. The second component is lack of understanding of the phenomenon and incorrect measurements. If the results of your measurements give you hope, suggest that there is a possibility of success, you tend to keep digging, right? That's normal. You're not getting any results, but you keep telling yourself that, well, Wright brothers never gave up, right? And that's why they succeeded. Don't fall into that trap. Now, the invention of airplane was inevitable. We've watched birds flying for thousands of years, so we knew it was possible to fly. The design of flying machines go as far back as the engineering itself. The design of Stark Dynamo also isn't anything new. I came across this design many years ago, and other than the name, nothing really has changed. Needless to say, it still doesn't work. Let's take a look at it and see how it's built. As you can see, it appears to be a rather primitive design of an 8-phase electric motor with neodymium magnets. Each coil is independently driven by a dedicated controller board. I assume that it detects the position of the magnet and energizes the coil to either pull it when it approaches and push it when it moves away. Now, the theory is that if you connect the load to half of those coils and keep the other half pushing the rotor, the load will dissipate slightly more energy than it took to push the rotor. Free energy forever. Where is that extra energy coming from? We don't know. The design doesn't touch on the subject of thermodynamics. There are several reasons why it won't work, but most notably, without using any math, just common sense, there are heat sinks on each driver. Why? because they are not 100% efficient. They dissipate energy in the form of heat. Even if your theory of coils picking up more energy than has been created, the device itself will not be close to 100% efficient. For this device to even have a chance of working, it would have to produce no heat. So the presence of heat sinks determines failure right from the start. We don't even have to go further than that. That alone proves that the device will not work as a generator. But let's see it in action. Okay, so the technician will now connect this questionable multimeter to the pickup coil and start connecting driver coils to spin the rotor. We don't know what is the power consumption of the drivers, but we do know that they are 12 volts and with a capacity of delivering 5 amps, which gives us the maximum of 60 watts per coil, or at least theoretically. The RPM was mentioned, and using RPM we can calculate RMS, but we're not doing math, we don't need to. As the rotor spins, you can observe that the voltage steadily rises on the output. That's because we have capacitance on the output instead of resistance. That capacitance likely comes from the meter itself, I would say. Oscilloscope and the resistor would be a lot more adequate tools to use here. It would give us the true RMS on the output. The technician seems to be very pleased with these results, despite them being meaningless. The voltage is only half of the equation, and since the resistance is 0 ohms, the voltage is free to rise to even ridiculous levels like that, especially if there's capacitance on the output. Yeah, that makes sense. The voltage shown here should explode all these LEDs, but since there's probably nanoamps of current available, then the voltage drops very quickly under load and causes nothing but a tiny flash on those LEDs. And in the beginning, you can see that the manual spin of the rotor quickly registers on the meter. The voltage rises very quickly. And there is no kinetic resistance on the rotor. If you connected, say, 10 ohm resistor to the coil, you would quickly notice that it's much harder to spin the rotor. The current induced in the pickup coil now works against the motion that produced it. That's what is it, the Lenz's principle or whatever. So there is a lot of kinetic resistance. That's the second reason, that's the second main reason that this doesn't work. It's actually, it is easy to miss this phenomenon if you only focus on the voltage, as our technician is focusing over here, and you base your math only on that variable. Well, the second variable is missing. That's why your equations are making perfect sense. You're getting more energy out than you put in. Yeah, you put 12 volts in and you get 500 volts out. Okay, but you put 60 watts in and you get 2 watts out, right? Okay, so now let's consider this. Let's do a little thought experiment. Say the driver coil must use 12 volts at 2 amps for 1 second to move the magnet, to put the magnet in motion. Now the magnet has been put in motion and it approaches the pickup coil. The pickup coil will experience moving magnetic field, right, and react to it, inducing current flow. However, the magnet is not moving as fast as it did when it left the driver coil. It slowed down a bit due to friction. Otherwise, if you turn off the device, the rotor would be spinning forever, right? It stops eventually because there's some friction. So we know that it must have slowed down in between those two coils. So that's energy loss number 1. The coil has some resistance, right? Which will resist that induced current flow. The energy will be dissipated as heat on the coil. Now, to recover all the energy created by the driver coil, we must use the entire kinetic energy that's resulting from that driver coil. So the rotor must completely stop at the end of the cycle. That means we've used the entire kinetic energy that put the rotor in motion. Now, if in this case we induce 2 amps at 12 volts for 1 second on the pickup coil, right? Perfect ratio. What we put in, we got out on the other coil. We still don't have a perpetual motion device because if we feed that energy back to the driver, some of it will be lost there. Remember those heat sinks? They'll eat up some of that energy. And of course we know we would never recover that 24 watts over 1 second on the pickup coil. So, but even given that, I mean, maybe with superconductors or something completely impractical like that, maybe that would be possible. But again, that's completely impractical. And now on top of that, we have energy losses in the driver, which we mentioned. And on top of that, we have energy losses in the power supply that supplies this entire device. We need to drop that 120 or 240, 230 volts from the outlet to 12 volts. That's not going to be 100%. Say it's going to be 95, maybe. Some power converters can actually go to relatively high efficiency ratios, but nowhere close to 100. Obviously, there's going to be some losses. There's also heat sinks in that power supply that supplies your free energy device. So you would have to pick up a lot more energy from this process to account for all those losses in the device itself. There are just too many spots where we lose energy on this device to even approach 100% efficiency, let alone produce any excess. The whole idea is dead on arrival, and it's a waste of time and money to keep chasing it, especially after 10 years of failure. At some point, you just have to accept the defeat so you can just move past it and potentially achieve success in the future.